discovery. And I think a lot of us really just enjoyed ourselves being together. That's the main part of being in that beautiful dark sky together and enjoying one another's company and the sky around us. The next weekend, we had a public event, which was also very successful. Again, Jerry spoke. Jay gave a talk on aurora, but we had spaced it so that we did solar observing in the afternoon with about 140 people or something like that come and go. And then we packed up those scopes. In the evening, we set up in the field behind the interpretive center. And Jerry did a presentation with a number of volunteer children on the planets and their distance and what they have as various characteristics, their distance from the sun, the scale of the solar system. It was really marvelous to see everyone enjoy that. Then we had a break. We showed people the moon, which was low, low in the sky before it started to set behind the trees. And then people went back, had the talk on aurora. I think there were still almost 100 people at that point, and then people returned to the field and looked at the dark sky. Jerry did a bit of a tour of the heavens with the laser pointer again, and people really had a good time. We had very good feedback from people. Mostly, again, because there are a number of different telescopes, different kinds of people interested in seeing things, and children of all ages could ask questions wherever they were and get something out of it. And one of the features of this year's event for the public was that a previous winner of our Telescopes for Kids program telescope was there with her telescope showing off the moon and objects in the sky. And her whole family was there, and it was marvelous. Her younger sister was there. They're in the audience somewhere. It's a little dark. There they are, the bottles. And they become real supporters and advocates for the Scopes for Kids and for RASC. So say hi to them at the break. Workshops. Stan Runge is organizing a couple of workshops. I've put vague titles here and sort of tentative plans for the dates. Stan, do you want to say anything?
Yeah, the first one is Richard Conrad's coming back with another presentation. It's been well received before, so it's called it number 2. It's processing astronomical data using STAR tools as the software. So that one's on the 18th. How do people sign up for that one?
They can sign up. It's free, but you have to go to Eventbrite. Will be put up probably and some other than find information. You should register as quick as you can because their seating is limited.
Yeah, so that's courtesy of Wing's arrangement at Launch Co-working. The space is really good, and it's kind of a classroom setup, so you can bring your computer and an image will be provided, I believe, or you could probably bring your own image. And then Richard will go through STAR tools and show you how you can really make something out of your images.
The second one, star hopping, that's one that I'm doing. It's going star hopping will be 2 workshops. So this will be the first one, which is really a beginner's one. The first one is really tied closely to Explore the Universe and the whole program associated with Explore the Universe. So I'm looking towards doing that sometime in November when we have a date and a location worked out. We'll do it then. That one may, right now I was going to do it during the afternoon, but that one may turn out to be one that we hold it at the observatory for a small group. It's an experimental one just to see how it runs. So I'm going to take names of people who are interested in it tonight. And yeah, I'm looking to do about 10 people at the most. Run through it and see what we need to do to adjust it. But that'll be sometime in November.
Okay, thank you. And while everybody knows who Stan is, I should say he's coordinating our calendar sales. If you've signed up to get one of the RASC calendars from National, you can pay him anytime. He would be glad to take your money, so he doesn't have to do it at the end when he's got the calendars and no money. And there, I believe, are 3 that are not spoken for. So if you would like one, rush over and get one of the last 3. Okay?
Last 3 are gonna be $20 a piece.
Right. The
You
first,
can sign up early, got for 15. The
Right.
last 2 are 20, we're gonna have
Last one goes to the highest bidder.
right, the last one goes to the highest bidder. We have calls for volunteers on 2 events. One is Teepees and Telescopes, which is an event that used to be coordinated by Sylvie and Jerry, I believe, in coordination with Wilford Buck. And this year is happening September 19, 20, maybe 21. It's a camping setup. The telescopes will be right near your camping site. You just bring your tent and food is provided. So it's kind of luxury camping, in my view. Scott is coordinating that one, and we have some volunteers, but some additional people would be very welcome. Smart scopes or observing telescopes or binoculars, whatever is available, right? So you can see Scott at the break for that. And the other event is the second year of the Southwood Circle properties at the University of Manitoba. University of Manitoba Properties Incorporated is the corporation that is coordinating development of what used to be the golf course around the university. So all the stuff that's been dug up and re-landscaped, the stuff north of the stadium, up toward Victoria Hospital, almost Pembina Highway further north. So that event is October 11, if it's clear, and October 12 is a rain date as a backup. And James Fast and Ivan are coordinating that. Last year, this was an incredibly successful event, in no small part to the coordination of Wing, who's been the liaison with Properties and came up with this idea. About 500 people came last year, many families, many with children. And this year, they proposed to improve it even more. I don't know if that means more people, but more organized, I suppose. This is the Thanksgiving weekend, the Saturday or the Sunday. So depending on the night, you may or may not be available, but at least you know, and you can see James. James, do you want to wave? James is over here. You can see him at the break if you're interested in signing up for that. Members Observing Night is tomorrow night, the 13th, I believe. And I've said 7 p.m. on the 18th of October, but I think maybe tomorrow would it be a bit later?
Yeah, I think it's
Like
8 or
8?
8:30. The
Yeah.
Winnicentrics says that.
Okay, the times are in Winnicentrics.
And they-
That's at Glenlee, and the map is in Winnicentrics. The Telescopes for Kids program that we've been fundraising for and collecting donations of telescopes is being reactivated, and we will shortly be announcing the date that the program will launch and the date and open the date for applications. We'll post those applications online so that people can apply. So this is for young children. I don't know, I don't know exactly what the age limit is, but it stops when you're, I don't know, 15 or 16, somewhere in there. And we've done this for a number of years now, and it's been very successful. Usually we have 4 or 5 telescopes and a youngster applies, and depending on the creativity of their writing or drawing or video or something, their interest and their keenness is what we're interested in. And we try to foster that and bring them into the RASC mentorship scope. The last announcement is about Winnicentrics. Our editor for the past few years is Scott Young, and he's done what I personally feel is a great job putting articles together, sometimes twisting arms to get articles, writing articles himself, compiling pictures or sketches or drawings that have been put together by members and putting it out before a meeting 6 times a year. Scott would like to pass the torch to someone else who's interested, someone who's interested in maybe maintaining the history of the organization, taking it to the next phase. The council has been discussing what to do with Winnicentrics. Do we need it? Do we want it? So we've come up with a 1-question survey that will be circulating to you through groups.io to all members about whether you read it, use it, want it, that kind of thing. And then we are also seeking people to take it on. Usually one person is the editor and maybe there's helpers on a regular basis, regular columnists, irregular columnists, once in a lifetime columnists, people who volunteer just out of interest to write something so that other people can learn about it. Winnicentrics has been around for a very long time. In my much, much younger days, Jay and I were editing that together and typing it and running it off on a Gestetner machine and mailing it with stamps that didn't stick. You had to lick them. So it goes back a long way, even for me. So it's kind of a neat thing to think about how far it's come. So you can see Scott or me or anybody. If you're remotely interested, there'll be a transition period. We won't just dump it on you. The format's pretty much set, so anybody who's interested can see us at the break. So I just have a couple of the pictures that I took. One of the things that happened at the public event was Jerry took people before the sun got too low off it to the side where you could see the sun, and he handed out golf balls to all these little kiddies, and they all learned what causes the phases of the moon. And I thought it was just brilliant the way that happened. And I can't post this anywhere because you can't post pictures of children, especially not with their faces. But I just love that picture of people holding up golf balls and looking at the shadow.
We can put icons over their faces.
We can put icons over every one of these faces.
Yeah, absolutely.
It won't be the same kind of photo, but anyway. And as a way of filling a little bit of time, because we're also always seeking people who would like to present something at the meeting. You can speak for a minute, you can speak for 5 minutes, you can speak for 10, you could speak for an hour if you'd like it. We can make room for what you would like to share with us. You don't have to be an incredible speaker. In fact, maybe it's more interesting if you just do something that you thought of that was interesting to you and tell us about why you did it and what you learned from it. You know, it doesn't take too long, maybe just one picture, maybe no pictures. We had a book review last year that was really quite interesting. So I put together one slide. I'm not sure they're going to really work here, but I think maybe you'll be able to see that there's dots on here, and then there's some streaks of color. So Jay suggested that I might want to try spectroscopy. Well, I have not ever done this. I've heard people talk about it at length. I understand some of the physics and the chemistry of spectra, but I hooked up a diffraction grating that Jay had in his toolbox with some of that red tape that was in the hospitality tent, and I glued it very gluey to the front of a camera lens, which ensued a large cleanup afterwards, but nonetheless, I did learn that you need to put the diffraction grating in a certain orientation so you can actually see the spectrum on the camera screen image. So these are a couple. The one on the left that's Vega. You won't be able to see it if you're online, but the bright star is Vega, and there's a spectrum there. And you may not appreciate the spectrum in its detail here, but I should say that the originals have lines in them, absorption lines, and there's a couple of places where I think maybe I see an emission line. And I know Vega has H alpha lines quite prominent. So I'm looking forward now to going and getting better images and scanning them along the line of the spectrum so that I can show you one of those really cool pictures of the spectral lines in Vega. And on the right, the stars of the Dipper are all there. There's the Dipper. And then these are the spectra of the stars in the Dipper, these streaks out here. Plus a whole bunch of other spectra from other stars in the neighborhood. When you're using one of these, the spectrum goes this way and the lines go perpendicular to the spectrum. But if the stars are moving parallel with the spectrum, you get just color. You don't get lines because it's blurring it from the movement. So you need to have the motion, the drift of the stars perpendicular to the spectrum, which was a whole other trying to make the 3D thing work in your head. After positioning the Dipper in the field, which was a major victory in the dark, then I had to figure out where the drift was. And wouldn't you know, as the Earth turned, the drift changed direction. Guess why? Because Polaris is there and things are going around. So I learned a lot of physics by trying this from like gut simple. And I haven't done any analysis and I haven't repeated it, but Jay made a better diffraction filter that covers the whole lens and doesn't glue on so you can rotate it easily. So that's just a little bit of what I did. And I'm no astronomer. So if I can do that, I'm sure a lot of people took some fabulous images that night and the next night at Spruce Woods. Just an example of a little tiny talk somebody might want to give at the next meeting. The last thing is we use Groups.io for communications. Every once in a while, I know I get a message that says so-and-so has left the group. And I think, well, they haven't left RASC. So why have they left the group? Because if you're not part of Groups.io, you don't get invites to the meetings, you don't get notifications of events, you don't get our great survey, you don't know what's going on. You might show up to the meeting, but the meeting might have been changed, location or date. So please try to join up with Groups.io. I think you're given that invitation to join when you first join RASC. Mark Saracen is the person that does that for us. And then there's a number of different groups you can join inside the Groups.io for sketching, for binoculars, for general discussion and image sharing and various bits of interest that you might have. There's also a buy and sell feature there, which I understand can get quite busy. Anyway, that's Groups.io, and we're hoping that people will stay a member of the general forum or join up to it so that they can chat more, because part of this is about what we learn from one another about the sky and about astronomy, and I guess also about equipment. So that's a lot of discussion. Now up to what's up, and that's Jay. And you're ready.
Okay,
We're running late, folks.
All right.
Sorry.
where's the rest? There we go. Probably. Here. And is that it? Is that it? Yeah, I'll do. Okay, it, right. Oh, you never give me enough light here to see these things. Problem with. Okay, just want to make sure. Okay, nightscapes, what's happening this month? Couple of interesting things going on in the next month. First of all, this is going to be the last one of these I show you, but it shows you how much daylight we have within that red box. And you can see that we have a pretty substantial amount of nighttime hours now. We're well away from the approximate darkness of the middle of summer. So now we have between 8 and 9 hours of observing time where the skies are what we call astronomically dark. Fitting name, but these are dark enough that you don't have anything to worry about polluting your night skies except for cities, other people, and satellites. The Milky Way, here it is in two presentations, actually the whole of the sky for two presentations. And you can see that in September, we still have a prominent Milky Way, but now it's not in the south anymore. It's in the southwest in the best parts of it. Where all of the nebula and darkness is. And that part of it is still one of the most interesting parts of the sky to be looking at because it's in that area that all the nebula and the clusters, the globular clusters and everything else, because we're looking into the center of our own galaxy and that's where many of the interesting things are. It's also the things that are nicest to photograph. And I know a number of us have got the C-Star and other automatic telescopes these days. And I think that I'll be showing you things that can be done photographically now because you can borrow one of those telescopes. You can buy your own for pretty nominal meaning under $1,000. It's the sort of way that astronomy is going. So you can see when we get into the October here on the right-hand side that the dark part of the Milky Way, the dust lanes is sunk even lower into the sky as it goes around toward the west. And at the meantime, on the opposite side of the sky, we see what we call the winter part of the Milky Way coming up. And that'll be, because these things are all rotating counterclockwise, that'll be coming up and being more prominent as we get into winter. However, with the Milky Way disappearing, you can see there's a big blank area of sky that's coming up on us with much less interesting stuff coming on. Still, we have another month, 2 months of, at least in the more northern part of the Milky Way in the center of the screen here. And then we go into a part of the sky where you have to search a little more for things. Planets right now, while Mercury is pretty much a dead loss, it comes out into the evening sky and it's quite a long distance away from the sun, but the way it's positioned for us, it's going to be coming out sort of to the side, so it's going to be low in the sky. It's not coming out vertically, so it's high above the sun. Venus is still really easy. You can't miss Venus in the morning, but it's getting lower and lower in the sky as it goes back toward the sun. It's also moving away from us. It's moving on to the other side of the sun, so its size is getting smaller. So in October, you'll see it's down to about 10 seconds of arc in size, and much smaller than it is when it's at its closest, where it's about 50 arc seconds in size. Mars is pretty much gone for us. You can still find it in the evening sky. It's taken its time going in toward the sun, but it's really so small now, up around 4 arc seconds in size, that it really doesn't present much of a target for us. Jupiter's nice and prominent in around midnight. Saturn is also prominent. It's at opposition, meaning it's directly opposite the sun for us. So say at its highest at midnight in the sky. The rings have been opening up gradually, as Scott was showing us, but they're actually starting to close back again because Saturn describes an S-shaped pattern in the sky as we go past it. And so this retrograde motion causes it to go back to a flatter ring system. And then as the Earth goes a little farther along in its orbit, Saturn's rings will start to open up again. So for the next little while, they're going to be closed up at a fairly small angle. Uranus is up. It's always hard to find Uranus, but it is underneath the Pleiades cluster, so that at least gives you the right area of the sky to be looking in. Binoculars will show it to you if you know where to look. You have a chart with you and you can pick out that little dot. Neptune is even harder. The big advantage to Neptune is it's pretty close to Saturn. So if you can find one, you could try looking for the other one. We did it at Sprucewood Star Party, but it's just a little fuzzy green dot. And you probably want to have a pretty big telescope like the one that you can use out at Glenley to get it at least as a little bit of a round dot. Here is Saturn showing its September 16 and October 16 position. You can see the rings have closed up a little bit in that we get into October. Some interesting things. A lot of double transits, double shadow transits on Jupiter. Now, these things don't come by all that often. In fact, they come in 15-year cycles. And so we've had a number of them in the past. And unfortunately, many of them happen in the daylight or they happen when Jupiter's on the opposite side of the Earth for us. But we have two of them that are visible on September 20 and October 6. And I'll show a little bit about that in a minute. And then we have the zodiacal light, which I talked about earlier, and I'll just recap a little bit later on. This is its peak for the morning hours. So if you've got a dark morning and a dark sky, you'll want to go out and see it. I sort of say it's about as bright as the Milky Way. It's actually a little fainter than that, but if you can see the Milky Way, you can see the zodiacal light in the if you've got the right kind of skies. September 19, we've got a fairly close conjunction of crescent moon and Venus. Those are always nice because they sort of display off against each other. It's nicer when there's a crescent Venus and a crescent moon, but today this September conjunction, we only get the moon as the crescent. And then on the 9th, we have a 3/4 moon that's going through the Pleiades. It's actually a good opportunity for doing kind of observing you don't get very much without making a bit of effort, and I'll cover that in a minute. So here we are with October 4 transit and the October 11 transits. You can see one's at almost 3 o'clock in the morning, and one's at 4 o'clock in the morning. So this is not for the faint-hearted. And I didn't check to see what day of the week it was. But in this case, you can see the two satellites in this depiction off to the lower left. And we can see the two shadows on the planet. So those are worth seeing. Everybody who pretends to be an amateur astronomer should watch at least a shadow transit, and getting a double shadow transit is a little bit more interesting. We also have a shadow transit of Titan, the biggest moon of Saturn, past Saturn. This will be the last for 15 years here. And you can see that it's barely touching the top of the planet here. So the moon goes in front of the planet and casts its shadow. And so you'll be able to see both of them simultaneously. These are somewhat more forgiving times in the middle of the night, being just after midnight for each one of them. After these are gone, then we'll have to wait. But these are the last of 8 previous ones. I've done something here I probably shouldn't have done. Okay. Zodiacal. Oh, too many. Hold on. If I can find the button. Well, anyway, I want to talk about the zodiacal light, and here, let me do this. There we go. Zodiacal light. It turns out that, just going to make sure I'm in the right place. Turns out that the programs like Stellarium will show it for you, but here we have a depiction of September 22, the Milky Way off to the right-hand side, and the zodiacal light with Venus, and that's a big glow that stretches up along the ecliptic, which is the orange line in here. The zodiac or ecliptic is actually the track of the sun across the sky, and all of the zodiac constellations in it, thus the name zodiacal light. So it looks kind of exotic here, and it is this depiction is not particularly accurate because the actual light is more cone shaped that spreads out as it gets toward the horizon. It's a reflection of sunlight off of dust that's in orbit around the sun, in the plane of the Earth's orbit. Lots of dust out there in the solar system, and so it's particularly easy to see sunlight reflecting off of it. And there's a picture I took many, many years ago in Australia where skies were exceptionally dark, and we have the Milky Way going across the bottom of the picture, but you can see that arc of bluish light that goes completely across the sky. And the zodiacal light is not just an event that's in toward the sunrise or the sunset. And actually, that dust is there everywhere. And you can photograph it at other times too, but it does take a very deep sky and the right kind of exposure to be able to do that. And so I've drawn a line there across it so that you can see what I'm actually talking about. A lot of other stuff in there. Here are what actual pictures look like. So you can see one from New Mexico and one from Australia. Again, it's not very difficult to see it as long as you've got the right kind of skies in the morning or the evening. Moon is moving through the Pleiades, which I mentioned. It's hard to photograph that with such a bright moon, but what is interesting is to go out and watch it, because then you can watch the moon occulting stars and see it's not an instantaneous process, but it is an instantaneous process if you're watching it by eye, because it happens so quickly. Sometimes it drags out. If the star happens to be double, I'll call it one and then the other. So you may see a very slight delay of even fractions of a second instead of being instantaneous. But the beauty of this is you can go out and watch several of these from pretty bright stars with the as this moon goes through the Pleiades star cluster. So if you can photograph it, then you'll certainly be famous on social media, because the moon is so bright it usually washes these things out. But I got a kind of suspicion that somebody with a sea star might be able to get something out of this. And then we have this crescent moon and Venus very low in the sky on September the 19th. And these make pretty pictures just because the moon by itself is pretty when it's got that thin crescent. But you'll be looking very low in the sky in that morning when you try to do this. I'm going to talk about Orion. I did this before. Orion is really the star of the show. As the Milky Way disappears off of one side of the sky, Orion is rising on the other side of the sky. And it's always a favorite target because the nebula in the center of Orion is so prominent and so easy to see that even with a simple camera on almost handheld, you can take a picture of it in a couple of seconds. We get a picture like this. Now, normally I wouldn't say much about this because this is a long exposure photograph of all of the things in Orion, but you can see the nebula there, that bright fuzzy blob there that's in the lower part of middle, the three stars of Orion above it, the four bright stars that form the main constellation, that big arc of red that goes all the way around, which is called the Barnard's Nebula. You've got the red blob in the middle, which is where the horse head is, and so on and so forth. The reason I bring this up is because this is the kind of picture that the Sea-Star telescope, Sea-Star camera that you can borrow, or some of us own, or the dwarfs and other versions can take this kind of picture, even from the city. So it's an area worth exploring both photographically and with a telescope, and even for the nebula itself with binoculars. And so there it is for the sky this month. I just love AI for giving me. It's our tradition to do a cat at the end of these, mostly because of Gale. And I have to get to the other part of this here, which I will. No, not there.
You know how old the trend of Titan is?
This doesn't look like where I want to go.
This September 19th one.
Ah, here we go.
Well,
What am I seeing? No, that's not what I got on my screen. All right, who's our technical expert here? There we go. We need a light here. It's hard to see the screen. Okay, I want to talk about one thing, and that's Comet 3I Atlas. And I stands for interstellar, and you've heard about it. It's the comet that's come from outside our solar system, and which is now passing past the Earth, past all of the inner planets, and then we'll be hitting. It's coming in at horribly large speed. It's not going to stick around. It's just going right through and back out into the galaxy for another 70,000 years before it passes another star and gives another planet and people on it something to look at. It's got a nice typical comet with an icy nucleus. We don't know what the size is because can't really see it because it's surrounded by all of the coma, the stuff that it's giving off. But figure it's somewhere most likely around 1 kilometer in size, but quite a wide range as you can see there. It was discovered by this Atlas telescope system. It's part of 4 telescopes around the world that just look at the sky over a huge wide area. And they're actually looking for stuff that's going to run into the Earth. But you can see where they found this thing. You're sort of in the middle of the Milky Way. And when you look at this picture that shows the discovery image of it there, that inset, and that little tiny dot in among all of those stars, you got to have a little bit of appreciation for our ability to find things in the universe as we go by. Anyway, initially the image looked like this. You can see we weren't sure whether it was a comet at the beginning because it was just a dot, but once we got to look at it with some of the spaceborne telescopes like this one, you could see that it had a coma around it, which turned it wasn't an asteroid, it was a comet because of that. Although the distinction between the two of them gets a little bit fuzzy sometimes. So it's got what we call a hyperbolic orbit, meaning that it's not in orbit around our sun. It's just coming and then it's going. It's going to pass closest to the sun on October 29th, but it's going to be behind the sun from our point of view, so we won't be able to see that. None of our telescopes will see it or anything else like that. It's close to the ecliptic, which is the path of the sun, so it's a fairly flat in terms of how it's passing through the solar system, but it does get close to Mars in early October, and some thought about turning some of the spacecraft in orbit around Mars to take a picture of the comet as it goes by and maybe get some of their specialized instruments to do a little bit of a survey, a better survey of what it's made of. Passes close to us in December. So it has some time to play out before we will be done with it. So here are 2 images. You can see the one on the left shows it tomorrow night. And the comet itself is toward the bottom there. And it's approaching Mars, but there are several positions marked there where it's closest to Mars, closest to Venus, closest to Earth at the top. And so on December 20th is You can see the line from the Earth toward the comet, and that's when we're at its closest. But it's receding from the sun at that time and not expected to be particularly visible unless you make an effort. But amateurs are doing some interesting photography of it. Here's a light curve of it showing the brightness increasing, but you'll notice the numbers there. Magnitude 15. Well, I think my 25-inch telescope could probably see something at magnitude 15. I'm not sure that the telescope at Glenley could do that with the kind of skies we have at Glenley, but it is actually reasonably easy to photograph. If it wasn't so small, I'd say the sea stars could probably take it on if as long as you went into a dark sky. Thought that it might get up to 12th magnitude, which does make it visible through the big telescope we have out at Glenley for everybody to use. Here's its position in the sky. As it is, I've circled two positions, one for tonight and one for November 12, which is, by then it should easily be visible in the sky. You could see it tonight. It's that yellow dot there to the lower right of the Libra. But it's also just above the horizon. Trying to find a 14th magnitude object just above the horizon is probably, well, let's just say impossible. It's an interesting comet. It has a lot of carbon dioxide in it. In fact, that's the most unusual thing about it right now is that the enormous amount of carbon dioxide. And typically, comets have a lot of carbon dioxide, but not as much as this do. We measure carbon dioxide by its ratio with how much water vapor there is. And this has, as you can see from the spectrum over here, the huge big spike of carbon dioxide there, whereas water vapor is actually ice in this little bit of a valley that's in the middle of that thing. So the question is why is there so much CO2 and why is there so little water visible? And there's also this thing called carbonyl sulfide, which is important, but I'm not going to talk about it. So if it's got a lot of CO2, that means that the gases that are coming off are from carbon dioxide, which is frozen onto the surface of this comet. Now, carbon dioxide tends to evaporate at a fairly high temperature, but not as high as water. Water is one of the most stable compounds on a comet. It's the last thing that starts to evaporate off the surface, or sublimate actually off the surface. Carbon dioxide comes first. Other gases, which are like methane, are much more volatile, and they go while the comet's way out in past Neptune even. So the question here is, why is there so much CO2? Well, it's probably because there's so little water. So why is there so little water? Well, it hasn't got warm enough yet for the water to start sublimating or evaporating off the surface of this comet. And then that question is why is it that cold? And a couple of explanations. One is that it's a bright surface, so that it reflects the sunlight off of the surface instead of absorbing it and raising the temperature to melt the water. And the other is that the water is a little bit below the surface, and the surface is kind of a fuzzy, almost like a sponge-like surface, and the heat doesn't penetrate very well into it. But carbon dioxide, being more volatile, comes off. So we'll know whether that might be right when we go look to see whether or not water comes later on as we go closer to the sun. So here's some pictures from a satellite called Spherex. It has a fairly long wavelength infrared, so it can actually see the nucleus of this comet, but it can't resolve it. So it's 1 pixel in size or 2 pixels in size. It's too small. Up above, you can see the pictures of the comet taken in 3 different wavelengths. So one of them water, carbon dioxide, and carbon monoxide, and it's quite obvious how much more prominent the carbon dioxide is. I think the best one is this lower image here. And you can see that there's these black dots on it with the error bars above it, and the black dots, the legend is up at the top. And those black dots are sort of following along that purple line. That purple line is what Kuiper belt objects look like in our own solar system. And these are comets and asteroids, which are so far out in the solar system that they're frozen solid. But they do have a little bit of outgassing from some of the most volatile species. And this comet that's coming in seems to have the same kind of pattern, which suggests that it's, as we already know, something coming in from very, very cold temperatures, and which looks an awful lot like these primitive bodies that we have out in the outer parts of our solar system. So it may not be that unusual, really. We're just waiting for it to get close enough to the sun to turn on some of the things. A couple more pictures of the comet in light of various gases, CO, and these are taken with a little more sensitive satellites, so you're beginning to see some details in the other wavelengths of light. And then we now know that it has a tail because here's a sort of broadband or white light image. The little white dot in the bottom with the arrow on it is the direction of the sun. So that what's unusual about this comet is the tail points toward the sun and not away from the sun. And that has to do with the way it's turning in about a 16-hour orbit. And of course, one side gets warmed up and the gases come off of it. And depending on which side of the view you will have of it, you can have the comet's tail coming forward instead of behind the comet. Quite untypical of the comets that we often see from our own solar system. So here's what it seems to be, at least as far as we understand it now. And it's unusual. We've had two of these before, and this one's quite a bit different, but it's got everybody's attention now. It's starting to head a little bit too close to the sun. You know, the Hubble doesn't like to point close to the sun, and neither does the James Webb telescope. There's probably a few more pictures to take of it later and get some more details about it. And just today, well, first I'll go through this. It's actually similar in some respects to this comet Hartley 2, which was outgassing. This is a picture from a spacecraft that went past it. And so because carbon dioxide is temperatures of about 100 Kelvin, which is about minus 170 degrees per Kelvin. So minus 70 degrees starts to sublimate. So we'll be watching to see this. Where'd it come from? Okay, it looks like it came from the thin disk of the Milky Way. The Milky Way is like a big flat disk. And so this comet looks like it didn't come from high up in the Milky Way, but it's coming along in the main disk of the Milky Way. They did trace back its trajectory, identified 93 encounters possible, of which 63 were statistically significant. But it turns out that these interactions made almost no difference to the path of this comet. And we can trace it back about 4 million years just by looking at where stars are and where it might have passed close to them. Last encounter, you can see, was 70,000 plus years ago with a small star, 84 light years away, and so on and so forth. That perturbation was a tiny little fraction, thousandths of arc second in the change in the position of this thing. So they went back to 4.25 million years and 500 parsecs distance, and they couldn't find any significant close encounters of this thing. So we have, at least in the recent history of it, a pretty good direction of where it might have been coming from. And then we get these other opinions about it, but we're sort of hoping these ones disappear a little bit. Of course, when these things first come in, they're so mysterious, and so the fuzzy-headed people get going on what it might be. I looked up this guy, George Cavacilius. Don't go there. Anyway, that's the most interesting thing I could find that's happening this month, Thomas Atlas. Thank you.
Okay, thanks, Jay. I think we'll still have a bit of a break now, maybe 15 minutes, and then reassemble here. Our speaker has done us an amazing favor of being here from University of Regina. So we'll be able to have a question and answer period in person, which is going to be great. Dr. Sam Lawler, we're looking forward to seeing her presentation. So 15 minutes and back in the theater.
There are books down here on the table for anybody to take away if they want.
Speaker in the back.
Yeah.
Oh, you got a presentation for?
No, she'll load it up now. It's Jake. Alan. Scott had to leave me.
Yeah,
I saw him leaving. I didn't know
why?
Yeah.
I don't know.
We can just take this right off.
Sure.
Hello.
Hello.
Shall I slide in here?
Well, we have a problem in it. This is on Zoom. I guess maybe.
You want to put it on that and we'll transfer it and delete everything when you're done with it.
I am on a Linux machine, so
Awesome.
so probably not gonna transfer anything.
Put this under.
I could also go on Zoom if you send me the link, maybe,
We
and
could
share
do
my
that.
screen.
Yeah.
Yeah.
Sorry, I'm just having trouble with my machine.
Just doing.
That's cool. There.
Oh.
Oh.
body.
Yeah, so it's like 220. Cancer.
I have that.
Both around training.
That's not. Or that's pretty tricky. I guess the technique.
Yeah.
Like you don't have to walk far, it's right.
Oh, I know what I need to do. There's a way to optimize. I'm gonna try this again.
It's gonna be
while we sort this out.
Okay, and,
Is that?
okay, sorry, and the camera's right there.
Oh, okay.
Okay.
Hi, everybody online. I'm sorry. So here we go with the light pollution from here on the prairies. We're really lucky that it's actually pretty easy to get away from light pollution. I know I give a version of this talk on Zoom in many different places around North America, and especially like the east coast of the US. It is depressing to pull up these light pollution maps. It's like, well, you could walk into the ocean and maybe get dark skies, right? Like there's really not much. So here on the prairies, we're really lucky. You can get out to really beautifully dark skies very easily, but a lot of people in North America don't have that option. However, there's another form of light pollution that has been ramping up very, very quickly over the last few years that you cannot escape from anywhere on Earth. And this is primarily driven by SpaceX launching they've launched more than 9,000 Starlink satellites into orbit. There's currently more than 8,000 that are up there. 2/3 of all satellites in orbit are owned by one private company owned by one billionaire, right? That's where we are now. One billionaire effectively controls orbit. And of course, the problem for astronomy is that these satellites are bright. They reflect sunlight long after the sun has gone down, and there's no rules about that at all. There's really not many rules about anything in orbit. So I'm really lucky that I live, I work at the University of Regina, and I live on a farm with lovely Bortle forest skies. So I'm really fortunate to be one of the few people who gets to see these satellites filling up my research data and also with my eyeballs moving across my sky, right? I'm sure probably the majority of you in this room have pictures like this with satellite streaks, right? You know, this is an astrophotographer in Saskatchewan, Janine, and I'm not going to try to say her last name because I haven't heard it yet. But that's, a 6-second exposure, right? There's so many satellites. This is 3 hours of data that have been stacked on the Canada, France, Hawaii telescope. And so when I first moved to a farm outside Regina, I noticed the satellites increasing in the sky. I could see it happening because I just happened to move there in 2019 when the first Starlinks launched. And so I wanted to, it's kind of selfishly, like this is the first time I've had access to dark skies at my house ever in my whole life. Why are the satellites happening now? So kind of selfishly and scientifically, I wanted to figure out how bad this was going to be. So I wrote a paper. So this is, so how many satellites are in your sky and how bright they are depends on the time of night and the season and your latitude on Earth, right? So it turns out that like 50 to 52 degrees north or south is the worst. Lucky us. This is an animation. We'll see how it shows up here. So this is on the summer solstice. Oh, I put the wrong one in. This is latitude 44. It's similar for latitude 50. It's actually slightly worse. We have a little over 100 naked eye visible satellites all night long. You can see that number down in the corner there. So pink, orange, and yellow are naked eye visible satellites, right? And you can see just due to geometry. So this is with 65,000 satellites, which when I wrote this paper, I thought that was ridiculous, but that is absolutely where we are headed. And that is Starlink brightness. So Starlink, to their credit, they have done a lot of work to put different kinds of coatings on their satellites to make them fainter. They've also made them much, much bigger. So they are just as bright as when they first launched. So this estimate of 65,000 satellites, the same brightness as Starlink, was actually not bad, and I hate that. What's just because of geometry, right? They're all at your zenith. All the brightest ones are right above your head. all night long in the summertime. Okay, so I will spend a lot of time complaining about Starlink. Starlink's just the first, right? There's many planned mega constellations. They're all way too bright. All the measurements that have been done. If there's time later, you can see the nightmare animation of AST Space Mobile, which is making these gigantic satellites that are as bright as the brightest stars in the sky, and they want to have 200 of them. So yeah, this is bad. This is not going well. Every single company that's launching satellites is brighter than the recommendation, except for OneWeb, which is actually doing okay. And I happen to be working in the most strongly affected part of astronomy research, which is wide field imaging. I look for Kuiper belt objects. So I'm looking for kind of a typical Kuiper belt object I'm trying to measure is magnitude 25. So if you're familiar with magnitudes, magnitude 6.5 is about the faintest that you can see, and then smaller numbers get brighter, right? So larger numbers. So this is really faint, right? And a typical Starlink satellite is millions of times brighter. So we've actually had to change our algorithms that have worked for many years for finding Kuiper belt objects, because you can see there's a little animation there. That little Kuiper belt object we actually missed at first because it got blasted by a Starlink satellite flying over it. Okay, but I want to tell you a little story that happens to work really nicely with all of the Saturn introduction that happened. So I'm one of the co-principal investigators of the Class E survey. We're trying to look for the smallest and most distant Kuiper belt objects using the Canada-France-Hawaii telescope. This telescope uses Q-based observing. So I program in, I say, I want you to look at this spot on the sky when the conditions are this good for this long. And then they fit that in with all their other observations. And it's fantastic for Kuiper belt research because it lets us get many visits. It actually works less well to have a full night of observing. So this way it gets slotted in over the course of months, but it's quite a lot of work, right? So I get images back like this. So I put in my coordinates the night before. I look at them in the morning and I say, perfect. Okay, I see, some of these little dots will turn out to be Kuiper belt objects. There's some annoying galaxies in there. That's not what I'm looking for, but great. Except for one day when I looked at my pictures in the morning, I saw this. Like, oh no, what did I do? Oh no. So it turns out that all of our fields where we're looking for Kuiper belt objects are in the ecliptic plane, and I forgot to check where the planets were. This is what happens when you take a 5-minute exposure of Saturn with a 4-meter mirror. Not good, right? So so I felt really stupid, right? Because I feel very much obligated. I am using taxpayer-funded research time, and I made a mistake like this. Oh my gosh! But so this is what here's a lovely picture of Saturn. We saw a whole bunch earlier, right? I'm sure almost everyone in this room has taken a better picture of Saturn than this, right? So, but what was delightful is Edward Ashton, who is a postdoctoral fellow at Asia A in Taiwan. He was actually looking for new Saturn moons. And he very carefully placed the pointings of the telescope around Saturn. And I accidentally pointed right at Saturn, which was not something that he was going to do, but it turned out to be useful, right? He could fill in the gaps right in close to Saturn. So I accidentally helped to discover 128 new moons, which is pretty cool. So we already talked. So this is from the discovery paper. I really like this. So you can see those are the pointings that Edward planned, right? So mine was right in the middle, blab. but it ended up being helpful, but not something that not something that a time allocation committee would say, oh yeah, sure, go ahead and point at Saturn. It probably won't break the telescope. So those are the motions of the moons on the sky as Saturn is moving and as the Earth is moving, right? You can see there's some really weird motions that happen that Edward had to calculate, and he did all the work and found all these moons. And so, yeah, so we already looked at this picture today, but I think it's a really great highlight of the kind of things that are going to get much harder to do as we get more and more satellite streaks, right? This is super interesting. Why are there so many more backwards moons than forwards moons, right? That's not something that anybody expected to find. And if it gets harder to do that kind of science, as we add more satellite streaks, that's something that we're going to lose. Another bit of science that we're going to lose, that we're in the process of losing, is trying to understand the observation biases around the solar system when we're looking for Kuiper Belt objects. So this is my area of research, right? So you can see there's this picture of looking down on the solar system, all these big loopy orbits. Those are the most distant known Kuiper Belt objects. And at first, like, there were 6 of them that were all pointed in the same direction, and that was pretty interesting. And a couple of different teams proposed maybe there's a giant planet in the other direction that's kind of constraining those, right? So as we've discovered more Kuiper Belt objects, you can see that there's definitely an asymmetry there, but it's not like everything's on one side of the solar system. So that particular argument has gotten a bit weaker. But in order to know, like, did we really not find Kuiper Belt objects on one side of the solar system because there's none there, or because of observation biases, right? So here's another way of looking at this, right? So now, again, looking down on the solar system, the red dots are those same big loopy orbits, like where they are, and the white shows where we would have been able to find them, right? And so you can see that we find these very distant Kuiper Belt objects where we looked in the solar system, right? Which sounds ridiculous to say that out loud, but there's biases built into this, right? You can see that there's kind of 2 directions that we've been able to search really carefully, and a couple directions we haven't been able to search, right? And part of that is the plane of the Milky Way, right? It's really hard to find new fuzzy moving dots in front of the Milky Way. Often in one direction is winter on Mauna Kea, and it's just harder to get time. The other direction is, I think it's the Coma cluster, some cosmology thing that it's just harder to get telescope time if you're not a cosmologist at that time of year, right? So all of those biases, which are totally non-intuitive, are built into every single Kuiper Belt survey, right? So the Classy survey, where I accidentally looked at Saturn, is these thin red slices, right? We're trying, the green slices there are the white ones in the other plot, right? So we're trying to do a little bit better job looking all directions. And we have wrapped up observing for this survey, but it turns out because of the ecliptic is at different heights in the sky at different times of year, right? In the summertime, the ecliptic is lower in the sky where we're looking. So there's more satellite streaks in our data. So this is a new bias. So we can't even compare with old surveys because this bias is there, right? So this is a way that satellites are changing the science that we are able to do already. Okay, so I have to quickly just remind everyone that I have been yelling about this for a long time. I have talked to so many different reporters, and it's kind of embarrassing how much I've been in the media yelling about satellites being too bright. But that's really important context for why it was so incredibly strange when this happened. So I think it was late April of 2024, I got a phone call from a reporter that a farmer nearby me had found spacecraft debris in his field. And I said, yeah, right. and then I saw a picture and said, oh no. Oh no, that's space debris. Oh no, this is my problem. Oh no, because I'm the only professional research astronomer in Saskatchewan. So this is my problem. So how did this happen? So this is the Axiom. So Axiom Space licenses, or they get private astronauts to pay them to shuttle them to the space station, which is pretty wild. I didn't know this was a thing, but I encourage all of you to go look at their website, even though you're probably not billionaires and not their target audience, because it's weird stuff, right? So these are private astronauts who they went up to the space station. I think these are all from. These astronauts are all from countries that don't have their own space programs. So it's not quite billionaires, but it's still private astronauts. It's weird. So these guys went up to the space station. They came back to Earth on February 9th. They splashed down in the Atlantic Ocean. So part of their standard operating procedure, right? So this is a Falcon 9 Crew Dragon. Up in the top is where the astronauts sit, and then there's this part underneath called the cargo trunk, and that's basically just they put big things in there that need to go up to the space station. And then when it's time for the astronauts to come back home, that the Crew Dragon trunk and the Crew Dragon detach from the space station. The trunk detaches. And then the astronauts land safely, and the trunk orbits around for a while, and then it lands somewhere. And SpaceX says, "Don't worry, it'll burn up." So it did not burn up. So farmers one farmer, Barry Sawchuk, went to the media. Lots of his neighbors also found pieces, right? This is not just one farmer finding one piece. This is many, many pieces. And they found them as they were prepping for spring seeding, right? The pieces fell in February. This is a pretty sparsely populated area, so fortunately it didn't hit anybody's house, so nobody noticed the pieces until they went to check their fields before seeding. Once I realized this was real, the first person I emailed was Jonathan McDowell, who is an astronomer at Harvard, and for fun, he runs the best, most complete civilian database of launches and reentries. So I just emailed him and asked, so was there anything that could have fallen in Saskatchewan in the last 7 months? And he immediately sent me back this plot. Yep. Axiom 3 Crew Dragon trunk. It flew over, and this is its last ground track. It probably landed near Regina. Like, oh, wow, that was fast. So SpaceX has this story, which I no longer believe, that a lot of their spacecraft are fully demisable. They will burn up completely in the atmosphere. But I have seen some very, very big pieces. And what's really terrifying to me is everything that's in low Earth orbit, all those thousands of satellites, all those millions of pieces of debris, the end of life plan is to burn it up in Earth's atmosphere, right? And whatever doesn't burn up makes it to the ground. Okay, but back to the story. Who do you tell that you found space junk, right? Like suddenly I'm in this position of like, I am the only official person, right? And I'm an astronomy professor. This is not supposed to be my job. Who do I tell, right? So my first impulse was, okay, I've emailed a couple of people at the Canadian Space Agency. Maybe they're the right people. And the people I emailed wrote back and said, I don't know, email SpaceX. I'm like, come on, like SpaceX is not going to respond to me. They don't respond to anybody. So one of the neighbors called the Transportation Safety Board, right? That's who you would inform of a plane crash. That makes sense, right? They never called him back. I tried calling the Turn-In Poachers and Polluters hotline and had a hilarious conversation that went nowhere, but it was funny, right? But like the rural municipality of Tullymet does not want to sue SpaceX. Come on, like that's for littering. Like, come on, that's not going to work. So what I've been told now is that the RCMP is the right people to call, but like I have extreme doubts about how that would actually be any better than any of these other agencies that I tried to call. I know that the Canadian Space Agency is working on something, but they won't tell me what, and they won't tell me when they have a plan. So something is coming. They will have a plan, which is good because a lot more stuff's going to fall on us. But for this particular initial space junk fall, what ended up being the most effective is Ituna, Saskatchewan, the closest town to where the debris fell, has a population of 600 and a teeny tiny newspaper with one journalist. And she wrote up the story. She believed the farmer when all these other journalists did not. That was how it finally got taken seriously. So support small town journalism. Great work. So yeah, there's very little precedent for what to do about this, right? The only actual laws are treaties from the Apollo space race era, right? And the only time that it's actually been tested prior to the recent billionaire space race was over Canada in 1978. A nuclear-powered Soviet satellite exploded over the Northwest Territories. There's a really great, really depressing podcast called Operation Morning Light, where local Indigenous journalists a couple of years ago went and interviewed a whole bunch of people who are still affected by this today. And the Soviet Union paid Canada some piddly amount of compensation. And that's that, right? That's the only time this has been tested. These treaties were set up in a time when only governments were launching things into orbit. So they only applied to governments. That means that when SpaceX launches something and it falls on somebody's house in Brazil, the US government has to pay the Brazilian government. The SpaceX is not part of this. The individual whose house is hit is not part of this, right? So that's going to be interesting when that gets tested. But what got tested here is who has to clean up when there's no damage, right? Apparently these guys. So SpaceX sent, so weird. So SpaceX sent these two guys who showed up in a rented U-Haul. And Barry Sawchuk had asked me if I would like to invite journalists to make sure that SpaceX stayed honest. And like, sure, I can do that. So I do feel kind of bad because these two guys showed up and there were like a dozen journalists waiting for them in the middle of nowhere, right? And then they got chased across the yard because they wouldn't answer any questions. And it got really, yeah. So at first they wouldn't even say they were from SpaceX, which was like, well, then who are you and why are you here? And then they did not answer a single question the entire time. So it was a lot of really awkward silence while journalists yelled lots of questions. I finally realized, so I had brought donuts because I didn't want all the journalists to be annoyed at each other because I invited all of them. But it turns out they all know each other and it was fine. But the donuts helped. And I thought, well, this is going to be my only, I mostly hung back and let the journalists do their job. But I realized like, this is going to be my only chance to talk to SpaceX directly, right? Like they never answer anything from astronomers. So, hey, SpaceX guys, do you want a donut? And I tried really hard. Someone behind me, one of the journalists behind me said, it's okay, you can trust her. She's not a journalist. I said, no, I'm an astronomer. And I'm pretty sure that's what I look like. They did not take any donuts and they did not answer my question. So oh well, I tried. So they loaded up the space junk into this U-Haul. I don't know what they did with it. I would like to think that they brought it back to LA and tested it to find out why it didn't burn up, but like they could have chucked it by the side of the road. They could have taken it to the Regina landfill. I have no idea, right? And I will never know. They never apologized. To my knowledge, SpaceX still has not publicly acknowledged that this was them. NASA publicly acknowledged that it was them, but SpaceX has said nothing about it. It is so weird. And this is how we work, right? This is how orbit works. Uncontrolled reentries like this one are supposed to have a less than 1 in 10,000 casualty risk, right? Which is surprisingly high. And, you know, we have all these examples of space debris. There was another piece of another Crew Dragon trunk that fell on North Carolina while all of the Saskatchewan stuff was happening, right? There's so much, right? So many pieces of debris. And the debris is happening more and more often. My computer's trying to play an animation and it's not doing it. Oh, there we go. And it's, you know, a giant explosion. So that's appropriate. It's having trouble. But yeah, right. SpaceX has all of these explosions that leave debris all over the Caribbean. Like, who's cleaning that up? But what's much scarier is this 1 in 10,000 casualty risk, right? So Starlink alone plans to deorbit about 10,000 satellites per year as part of their disposability, right? This is the mega constellation model. Build lots of things fast and cheap and throw them away, burn them up in the atmosphere, and they're just gone. And they're not small satellites. People think, oh, they're nano satellites. No, they're big. The ones that are up there now are the size of a Ford F-150. The ones that they're talking about launching are the version 3s are a couple of tons, right? This is wild stuff. And low Earth orbit is getting crowded, right? This is looking at the total amount of stuff in orbit over time. You can see the orange is the active satellites, the payloads, right? And you can see there's this like hockey stick that happens in that line in 2019. That's Starlink, right? You can see it in this plot. And you can see there's these jumps in the green line. So that's the debris. Those are collisions and anti-satellite weapons tests that create a huge amount of debris. You know, we're just waiting for the next one. So speaking of waiting for the next one, so this is a figure from a paper that is very close to being submitted that gives me nightmares. So this is looking at, this is real data from orbit right now. So this is, you know, altitude versus time between less than 1 kilometer close approaches, right? So 1 kilometer sounds like that's a huge distance, right? But everything in orbit is traveling at 7 kilometers per second. So 1 kilometer is terrifyingly close. This is backed up by Starlink's own reporting. They reported 1 collision avoidance maneuver every 2 minutes on average within their mega constellation, right? So every 2 minutes, there's an opportunity for a mistake or a missed connection that could lead to a collision, right? You can see these close approaches are happening every few minutes. So that those dips there, that's Starlink, right? That's the densest, most dangerous part of orbit. This is a recent paper by Hugh Lewis and Donald Kessler himself, right? You may have heard of Kessler syndrome. It's this worst case scenario in orbit where you have collisions that continue making more collisions and more collisions. So yeah, that is named for his paper from decades ago. That seemed crazy at the time, but here we are. So the black solid line up there is the runaway threshold, right? So above that line, you will have an infinite number of collisions in an infinite amount of time, right? So it's not like Sandra Bullock watching the International Space Station get destroyed, right? It could be a very long timescale thing, but you will continue having more collisions even if you don't add anything else to the system above that line, right? And the gray line that kind of bounces along there, that is where in orbit we are above that threshold, right? And so you can see there's 2 bumps, right? So there's one bump that's at higher altitudes, and there's another bump. I'm going to squish this plot and compare it with our plot. Sorry, this is a little bit hard to read, but you can see that smaller bump at 550 kilometers altitude, that's Starlink, right? If we have a collision in Starlink's orbit, we are in Kessler syndrome, right? Like, it is wild to me that that they think that they can continue, like, so far their collision avoidance maneuvers have been perfect, but there is a huge price to pay if they make one mistake. There's also a huge amount of of pollution from launching all of these satellites, right? I mean, you can see a rocket launch, you can see there's a lot of emissions that come out, but it used to be that rocket launches were very infrequent, so it wasn't a big deal, right? But as more and more rocket launches happen more and more frequently, all of these exhaust products being deposited in the high upper atmosphere are going to start adding up. This is just sort of a summary of all of the terrible things that can happen at higher altitudes. I think the scariest one is the changing temperatures that can happen at the very high layers of the atmosphere where ozone lives, right? Like we need that. We also see the effects of rocket launches, right? There's these ionospheric holes that appear, kind of like fake auroras, and those are being studied by astronomers. But those are getting more and more common. What does that do to chemistry? I don't know. That's not my area of research. There's these noctilucent clouds, very high altitude clouds that are becoming more and more common as rocket launches increase. So again, like this is something that we need to be studying. Scientists need to be given lots of money to study this, and they are not. Okay, but I'm sorry, I keep escalating this. We'll get better. But this is the scariest part to me is the reentry products here, right? So Starlink conservatively says they want to have 30,000 satellites in orbit. Each of these satellites is 1,000 kilograms, right? 1 ton, again, conservatively. They all have a 5-year lifetime, a 5-year working lifetime. That means 16 tons per day will be burned up in Earth's atmosphere. If these satellites are 50% aluminum by mass, right? That's what most of their body is made of. We don't actually know the real breakdown because that's considered proprietary and companies won't share it. But that is very, very different than the 50 tons per day of meteoroids that naturally infall, right? Those are 0.3 tons per day of aluminum, for example, right? So at its peak operation, Starlink alone will exceed this by 25 times, right? Like, what is that going to do to atmospheric chemistry? They've already exceeded it by several times, right? So the latest Starlink conjunction report from July said that they had almost 500 reentries in 6 months. And these are smaller ones, so let's say 500 kilograms each to be conservative. That's 0.6 tons of aluminum per day, right? So Starlink alone in the last 6 months already doubled the natural infall rate of aluminum. Nobody knows what this is going to do. There's a few preliminary papers talking about how this could change atmospheric chemistry. It could change, it could create alumina, which could deplete ozone, but like nobody really knows. Nobody is studying this fast enough because there's not money for it. And then back in 2023, there was a paper that came out. They flew a high altitude plane and gathered dust from the stratosphere, and they found that 10% of that dust already has metal in it from rocket and satellite reentries. 10% already in 2023, right? So the purple line here is that same curve that I showed you before of the number of satellites on orbit, and you can see that hockey stick, right? So that 5-year lifetime, a 5-year operational lifetime, we're just getting to that. So the green curve is reentries, right? We're just starting the hockey stick in reentries now. So we're going to find out what that's going to do to the upper atmosphere. We're just running that experiment without testing anything first. It's really, really quite horrifying. And then whatever doesn't burn up will hit the ground, right? While that is, it's not as scary to me because it's not as globally far-reaching. This is actually what makes politicians worry a lot more, which I find very interesting. Right? It's a lot more visceral. Like, oh, a thing fell on your head, right? Like, I guess that's easy to understand, right? Okay, so I have to add another story to this. So in I think it was February of last year, Jonathan McDowell, the Harvard professor, and Aaron Boley, who's a professor at UBC, both joined me on CBC, Blue Sky, the local radio call-in lunchtime show, right? Super cheesy. And I wrote to Jonathan afterwards, just thank you so much for coming to that, right? Like, I'm pretty sure there has never been a Harvard professor on that show ever, right? Like, that was really cool. And he said, oh yeah, no big deal. We'll never have to do that again, right? So then 3 days later, he sent me this report, this official report from SpaceX on Starlink satellite demisability. And he said, you should read this. Like, okay, if Jonathan McDowell tells me to read something, I will read it. And it's just all this information about like, oh yeah, we're so good at burning up satellites. They burn up really well. Look at how good they are at burning up. And then at the very end of the report, there was this paragraph that said that the only piece of a Starlink satellite that has ever been found was found on a farm in Saskatchewan in August of 2024. And I'm like, what? What? So, my first thought was this has to be some kind of AI gobbledygook. Like, there's no way, like somebody copy pasted error. Like, this can't be real. There can't be another piece of space debris that fell on another farm in Saskatchewan. But no, it was real. So I went on another local radio show, and because Saskatchewan is actually just a giant small town, I made a burner email address and said, like, please email me if you have any information on this other piece of debris that fell somewhere in Saskatchewan, because I didn't know where. I had no idea where. So I expected to get a whole bunch of wacko, totally weird emails, right? But one person emailed me and told me who found it. Exactly one email, and it was exactly what I needed. So I've talked to the farmer. He sent me pictures. SpaceX, so he contacted SpaceX directly when he found it. He did not contact the Canadian government. He did not contact the Saskatchewan government. He did not contact the RCMP because nobody has told him to do that, right? There's no information about what to do. So he contacted SpaceX. SpaceX said, yep, just FedEx it to us, which I'm sure is horribly illegal, but okay. I would love to see the customs form. So he shipped it to them and they gave him a $5,000 check, and that was that. And he didn't even mention it to anybody until I asked about it. So, okay, so this is a small piece, right? So it's like a big laptop, a really big laptop. You wouldn't want to get hit by it. It would definitely be lethal if it hit you, right? But it's small. It's not like these giant, terrifyingly huge pieces from the Crew Dragon trunk. But there are 8,000 of those above our heads right now that have to re-enter, right? That is terrifying. But why Saskatchewan? Why are they targeting me? They're not targeting me. It's because it's really easy to find stuff here on the prairies, right? You go drive around the grid roads right before seeding season, you can see everything, right? And we happen to be under the densest band of Starlink satellites just because of the orbits that they've chosen. So just by probability, this is here on the prairies is the most likely place to find them. So the fact that we found one piece in the most likely place in the world to find it is terrifying, right? So assuming that every Starlink reentry has had one piece of debris hit the ground, here's the distribution, right? A lot of it is in the ocean. A lot of it is over forested areas, or maybe even in a city where you wouldn't know that's a piece of space junk, right? This is everything that still has to come down, right? This is where that could all fall. So this is just a probability distribution, right? But you can see there's a lot that's going to come down in Canada. So this is absolutely a problem that we will have to deal with more in the very near future. As everybody else continues launching satellites, right? Starlink is first, but there are 1 million planned satellites, right? That have been filed for. We absolutely need international regulation of satellites. There's this awful thing that I hate so much, and I will talk more about it and try not to cry, but this is the Reflect Orbital wants to have giant mirrors in orbit to shine onto solar farms. They would be bright enough to cause eye damage if you accidentally looked at them with binoculars, and not bright enough to power a solar, like a solar panel. So I don't understand what they're doing other than harming everything, but they have filed for their first satellite. They plan to launch it next year. I hate it. I hate it so much, and I will fight this one really hard. Starlink's internet isn't even that good. When you have more than 6 people per square mile, it is slower than broadband, right? So they are destroying orbit, causing massive pollution in the atmosphere and collisions on the ground for not even very good internet. It's so frustrating that that's where we are now. We can't have tens of thousands of satellites in orbit without severe consequences. We need to think more about how to use Earth's orbit today so that we can continue to use orbit in the future, because satellites are very useful, right? I spent this whole this whole talk just crapping all over satellites, but like they're so useful, right? Like I've probably used satellites without even knowing it several times today. We need to think more about how to prioritize the most beneficial satellites to the most people and not just whoever gets up there first. And we need to think about space law. How are we going to hold companies accountable for the damage that they cause? Right now, it's not looking great. Okay, so then my last, this is just so this is totally not meant to be a guilt trip to anybody. This is just like, when I see a terrible, scary talk about climate change or something, I want a list of things I can do. So here's a list of things that you can choose from if any of these work for you. Right, so SpaceX is a giant, powerful corporation. It will only respond to legislation, which is incredibly slow, or to consumer pressure, right? And legislation is totally not going to happen in the US anytime soon, right? So consumer pressure is what we have. If you have alternatives, don't use Starlink, right? But I realized that that's not an option for a lot of people, right? Especially if you live on a reserve or something, your internet options are terrible. I live in rural Saskatchewan. I completely understand why people are jumping on this. Another thing you can do is to talk to your local government, all levels of government, local, provincial, federal, about getting better internet to people in rural and remote places, especially First Nations. There's many ways to access internet that don't require a billionaire destroying orbit. To tell people what's happening in orbit. Most people have no idea how dangerous the situation is, so just telling people is useful. And then get outside and show people the night sky. All of you are doing amazing work with that. I was so impressed listening to the first part of your meeting, how much outreach you're all doing. Keep doing it. It's so important. Thank you. And get out and enjoy it yourself, because that is also important. It's changing now. There's a few groups, like the American Astronomical Society has a very active light pollution and satellite pollution committee that I got roped into being co-chair of. There's the International Astronomical Union has a group specifically for satellite pollution. Dark Sky International does great work. I'm trying to start something in Canada because I also accidentally got elected to the Casca board. So that's kind of my thing, is like, how do we fight this, right? So there's some options, and like, astronomers really are the canaries in the coal mine for this disaster, right? We are the ones who are noticing the changes. We are the ones who need to talk about it. But there's a lot of people who will join us in the fight. So thank you, everybody, and I will be happy to answer questions. Questions?
Further to your point about who's gonna clean up this stuff, there's this problem exists everywhere, mining, resource extraction.
Oh yeah, this is not a new problem.
And this thing is called private profit, public liability.
Yes, that's exactly what's happening. And it's even worse because it's international, so it's even harder to pin the blame on people. Yeah, it's absolutely not a new thing, and it's awful. Yeah.
Not sure, did you mention the UN and then Anyway,
So I went to a UN conference. It was the UN Committee on the Peaceful Uses of Outer Space, right? And it was super interesting because there were all these satellite operators there from all over the world, except SpaceX. SpaceX wasn't there. Everybody else was there. And the people from the UN, so all the satellite operators, everybody was saying the UN needs to regulate this. And the UN said, oh, we don't regulate stuff. We just provide guidelines. Like, so they have no power. They have no enforcement power, right? And so, yeah, so it's not working. There are discussions that are happening, but it's even slower than federal level legislation, right? So I don't think that's going to save us.
How big are usually the pieces that fall down from the satellite?
That's a really good question. So we don't know very many pieces yet. Those pieces that I saw in Ituna, those were really big pieces, right? So like some of the pieces were bigger than me, right? But that is not typical. And they actually, because of all of that press, they actually changed how they do the reentries now. So now they purposely reenter those over the Pacific to a slightly higher risk to the astronauts. But to that, I say the astronauts signed up for that risk. The farmers on the ground did not. So like Starlink satellites, only one piece has been found, and it was like this big, right? There's been lots of other pieces that have been found, but it's not clear which spacecraft they come from. So yeah, so all different sizes. I suspect that there's a lot of pieces making it to the ground that are really small that wouldn't even hurt you if they hit you. But still a big problem. So let me just make clear, like, this is not something that you need to worry about, right? The odds of any person, I will just say nobody in this room will ever get hit by space junk, right? It's just the probabilities are so low. That's not someone somewhere in the world might, but not you, right? Like the odds are just so low. So that's not a thing to worry about. So yeah. Yeah.
do you anticipate a new satellite technology that would displace the current architecture of these gigantic satellite, like small satellite constellations, like bigger satellites, higher up orbit, but fewer of them?
Yeah, so what I tell any satellite engineer who will listen to me is the engineering challenge is we need fewer satellites. So you need to deliver your services with as few satellites as possible and have your satellites live as long as possible, right? So like geosynchronous orbit, the satellites that are up there last decades, right? And they're large, like they build them to last, right? We need that in low Earth orbit too. But it's just like a totally different mentality because it's relatively cheap, right? It's the same thing with LEDs. Like, oh, it's cheap. We'll just use them everywhere. Oh, it's cheap to launch. We'll just launch everything and just burn it up, right? It's this disposability that's really, really bad. So that is what I want to see. I don't know if it will happen soon enough, but that's what we need in order to keep using orbit. Yeah. Yep.
Thank you so much for all the work you're doing on this. To be an advocate like this, you might not have any time to do your paper belt.
Not much, no.
I'm kind of glad because, this is really, really important. And I was wondering, do you have a counterpart in the prairies, or does the RASC have anybody doing this kind of?
I've been starting to talk to people, who did I talk to? There's one person from RASC who's reached out to me who used to be, is it Rich, yeah, yes. So he's reached out to me. I'm trying, like, this is something I need to do next week. It's on my list, my to-do list, is to try to figure out, like, what is something in Canada going to look like, right? Because we can't just say like, oh, because one possibility is like, okay, you satellite companies are disrupting taxpayer-funded Canadian science. You need to pay a big fine to Canadian astronomers to offset that, right? And then Starlink can just turn around and say like, the Canadian market's not that big. We don't need to broadcast to you, right? And then we get all of the downsides and none of the benefits, right? So it's tricky, right? Like, what can we do as a single country? But that's, I'll figure it out next week. Yeah.
Do you have a website where we can check what you're up to?
I have a website. I complain a lot about a variety of different farming and astronomy things on social media. If you want to follow me there, yeah. Blue Sky and Mastodon.
There's a dark sky or sky light pollution committee at RASC.
Yeah, yeah,
Nationally, but it isn't super active
yeah,
generally.
yeah. So that's who I need to connect with, and yeah. So that's my task over the next few months. Yeah.
Well,
If anybody has connections, let me know.
yes,
Yeah, I think I've heard of plans for a Canadian, sort of Starlink alternative.
Oh yeah, there's Telesat. Yeah. I'm supposed to talk to them next week too. They don't plan as many, right? Starlink still has like the most of any mega constellation that is up there. There's a couple that want to have hundreds of thousands, but Telesat I think is, a more modest like 3,000 or something, right? Which is still so many, but like the shifting baselines, right? It's yeah. So I don't know. I'm encouraged that they're reaching out to astronomers voluntarily. That's a good sign. But yeah, we'll see what they actually do. There's no laws.
Mike,
I wonder if this could be regulated by in terms of liability. Like you mentioned, it's really crowded in space, one accident could cause major cascading. And Starlink doesn't accept that responsibility, US government pays the dollar figure for that. How does that dollar figure get related to liability to law enforcement?
That's an excellent question. And I think so if Starlink did cause a, giant destroy a bunch of satellites in orbit, the US government would be liable for it, right? Not SpaceX. So yeah, this is something that will be tested legally because the framework is so old. But yeah, that's a great, there are a whole bunch of people going into space law now. And they will be deciding this and it will be interesting, but yeah, there's not a clear answer there.
well, if there's no other questions, there's one more, sorry.
What's going on? Let's tell them that's.
Oh yeah, that's so that one's actually that's quite well planned out. And they're thinking very carefully about how to not have any casualties. They're aiming for the Pacific, right? There's lots of plans there. What doesn't have a deorbit plan is the Hubble Space Telescope, which is huge and has a giant piece of glass that would totally not burn up in orbit. So that, and NASA's now like totally destroyed, right? So like what's going to happen with that? The ISS I'm not worried about because there are plans in place and other international partners. Hubble, I'm actually kind of worried what's going to happen. If they lose one more gyro, it could start spinning and then they can never do anything to catch it, right? So yeah, that's something that really needs to be planned out.
One more.
So sometimes I'll hear about plans to collect space debris in orbit.
Oh yeah.
Actually,
I talked to Astroscale, which is like the company that's doing it, and they're like, "Yep, we're gonna catch a satellite this year." So meanwhile, Starlink launched 100 more last week, right? So it's hard. It's really hard. And then even trying to catch little pieces of debris, they're all traveling many times faster than bullets in all different directions, right? Like this is a hard problem and it's much easier to not make the problem in the first place, but that's that ship has sailed.
Okay, I think I'll call it because of the time. Fascinating talk. Good luck. Actually, you could help. I mean, we do talk about those things. We see them all the time.
Yeah,
The public
yeah.
always sees them and asks about it. But if we could start something at RASC, that probably would be a good thing.
Yeah, I'll be in touch. Yeah.
And if you would like to continue this conversation with our guest, you're welcome to join us for pizza at Boston Pizza anytime now. Thank you so much. Thanks
everybody
for your
online.
interest and see you.
So.
Yes.
Yeah. Zoom sharing seemed to work okay.
It did,
Yeah,
yes.
yeah.
It was good.
A little slow, but it was.